In this video, we're going to look at parallelograms, how to compute the area, look at related problems. So a parallelogram is a quadrilateral, four-sided, and it has certain properties. The opposite sides are parallel. So these two sides are parallel, and then over here, these two sides over here are parallel. And they're also congruent. They have the same measure. So this side has the same measure as this one, and this one has the same measure as this one. Opposite interior angles have the same measure. So this angle right here would have the same measure as this angle over here. This angle here, opposite angle over here, would have the same measure. Another property is the diagonals. And these are the diagonals from corner to corner are not necessarily equal, but they bisect each other. So if this is 5 from this corner to where they cross, say the length is 5, then, or say the total length there is 10, and this part here will be 5, this will be 5 units, and say this one is the smaller one, this say would be 4, this will be 4, total length there would be 8. The other thing is interior angles on the same side are supplementary, that is, they add up to 180. So this angle and this angle add up to 180. If this angle, say, is 150, this one have to be 30. They have to be supplementary. Same thing over here. This one and this one. Consecutive angles. In the same way, this angle and this angle would be supplementary. Or this angle and this angle. Quick review of these properties again. Both pairs of opposite sides are parallel. Both pairs of opposite sides are congruent. That is, they have the same measure. Both pairs of opposite angles are equal. They have the same measure. The diagonals bisect each other. And then the same side for consecutive angles are supplementary. They add up to 180. Now we've talked about the square and the rectangle, and we know how to find the area of those. So a square and, say, rectangle are a special type of a parallelogram. They pretty much have the same properties. Opposite sides are parallel. Opposite sides are congruent. Opposite angles are equal. It turns out that for the rectangle and, of course, the square, all four angles are the same, 90 degrees. So you can say that a rectangle is a parallelogram with four angles, each measuring 90 degrees. A square, you can say, is really a rectangle. Has all the same properties except for a square, all sides are the same length. So you can say a square is a rectangle with all sides the same length. Obviously, they all have the same angles, measure 90 degrees. And we know how to find the area of a rectangle. Area of a rectangle is the length times the width. Sometimes they talk about the base. So base times the height. Pretty much the same thing. A rectangle has every side the same length, so if this side is x, the area is x times x, which of course will be x squared. Now for a parallelogram, it's kind of close to this definition, but not quite the same, because again, the structure of this keeps it from being, so I can't just say, let's call this the base. It's the length, we'll call it the base. And then the altitude of a parallelogram is the perpendicular distance from one side to the opposite side, or the side that or a line that contains the opposite side. So say that would be a perpendicular. This angle right here would be a perpendicular. Now sometimes the structure of the parallelogram might keep you from doing this type of thing, so you might have to do this and call this line here the altitude. Notice it's always going to be the same. If I draw it over here, or if I draw it here, that's the same thing because the lines are parallel. We'll look at some examples here. So find the area of the parallelogram. So the formula that we're going to use again is going to be area will equal to the base times the altitude, which we'll call h. A parallelogram will have two altitudes, and you can use either one depending on which one you have. But you have to use the base corresponding to that altitude. So in this case, we're looking at this side right here, and the altitude is dropped from this point here. So notice in this case, because he drew the altitude here, in order to go to the opposite side, the perpendicular is with the line that contains that side. So it could have been here. They're telling you it's 10. So you want the area. Okay. So you don't use this 20 here. Otherwise you'd have to use a altitude to this side over here. And it's not drawn. So in this case you'd have to say it's the base would be 12 times the altitude, and that's given to be 10. And then just in case it's not clear, and I probably should have given you this, I need to put a perpendicular here just to let you know that this is perpendicular. So then it's 10 times 20, and this is 120. And of course area is always in square units, so if it doesn't give you the units, you can just say 120 square units. So again, the area for standard parallelogram is the base. See, don't use this 20. Sometimes they'll put some numbers just to confuse you. So you have to use the corresponding side that goes with this altitude. Given parallelogram ABCD, you see it there, find the value of x. So you can see the parallelogram is ABCD, and notice it has a perpendicular from this side here, from the side containing segment CD, and it goes to this side over here. So if I want to look at now I want to find x, but there's some other things I need to find first in order to find x. So here I'm going to look at, let's find the area. So the area of the parallelogram, you can see the altitude there. It's perpendicular, so you can see it's an altitude from the line containing CD to the line containing side BA or AB. So in this case the base is 20, so that'd be 20 times the altitude, which is 6. So this would be 120. Now if it asked me for the area, that would be the answer. But it's asking me for x. But now that I know the area, now I can come over here to this side, and this now has another altitude. Remember, we said that a parallelogram can have two altitudes, but you have to use the appropriate side for that one. Okay, so in this case, this altitude, notice it's going to this side right here. So in this case you have to use the base 12. So the base is 12 then, so it's 12, and the altitude is x, so this would be times x. Now that's still going to give me the area. So you can use a different altitude to find the area, but as long as you use the corresponding side that goes with that altitude, the area should be the same. So this represents the area of the parallelogram, so that should be the same, 120. Now we divide both sides by 12. This divides out. 120 divided by 12 is 10. So they want the value of x. Value of x is 10. And go to the next one. So we're going to look at some word problems here. This says find the perimeter of a square with a diagonal of 14 units. So find the perimeter of a square with a diagonal of 14 units. Well, to find the perimeter, I need the length of the sides. I don't know that right now. So let's just label the sides x. It's a square, so I know that all sides are the same. And I know the length of the diagonal. I can draw it this way, or I can draw it from this side. It's the same. Since it's a square, both diagonals are going to be the same measure. Now, here I have a right triangle. Right here, and of course up here. You can take your choice here. So a right triangle, you see this is a square, so this is going to be 90 degrees here. That's 90 degrees there. the square of the hypotenuse is always equal to the sum of the squares of the legs. The legs are the sides of the triangle are x here, so it's c squared then is equal to x squared plus x squared, and in our case the hypotenuse is 14. So this can be 14 squared then, should equal to 2. Add the x squares together, that's 2x squared. Okay, so let's solve it over here. 14 squared is 196, and then this is 2x squared. And let's divide both sides by 2 here. And 196 divided by 2 is 98. So 98 is equal to x squared. And then 98 is 49 times 2. So I take the square root of both sides. Square root of x squared is x. And here, since I'm dealing with dimensions, length, I don't deal with negative numbers. So I don't take plus or minus the square root. Here I just take the positive square root. So square root of 49 is 7. And then the square root of 2 doesn't have an exact root. That's the square root of 2. So I'll leave it as that. So the length of each side of the square is 7 times the square root of 2. And you have 4 of those. So multiply that by 4. And the perimeter is 28 times the square root of 2. Now if it wants the exact answer, that's the answer you would give. 28 times the square root of 2. But if it wants an approximation, say to 1 decimal place and take your calculator and compute the square root of 2, and then multiply by 28, and this should give you 39.6. And now since we're dealing with perimeter, that's the linear length. So this is just 39.6 units, not square feet, or square units. So here we use the Pythagorean theorem. Again, in a triangle. You know this. You use this a lot in geometry. If you have a right triangle, the side opposite, the 90-degree angle, is called the hypotenuse. We label it as C. The other two sides are called the legs or sides of the triangle. That's 90 degrees. The other two angles are complementary because they have to add up to 90 degrees because the total number of degrees in a triangle is 180. And the fact that we need to know here and we used is that the square of the hypotenuse, C squared, is equal to the sum of the squares of the other two sides. In this case, there's your answer, 28 times the square root of 2, or approximately 39.6 units. So in this one, when we have the area of a rectangle is 180 square units. The ratio of the base to the height is 4 to 5. Find the perimeter and the diagonal of the rectangle. So again, here's my diagram. So the area of a triangle is 180 square feet, or square units. The ratio of the base to the height is 4 to 5. Find the perimeter and the diagonal of the rectangle. So this will be the base, and the ratio of the base to the height is 4 to 5. So all that tells me is that if I were to take the value of the base and write it over the value of the height, they would reduce to 4/5. So they have a factor in common. Don't know what the factor is, so we can just call it x. And then we use the information here. We want to find the perimeter and the diagonal. So we know then the area is 180 square feet. So let's just multiply 4x, base times the height. Should give me the area, which is given to be 180. Sometimes you have to piece these problems together. 4 times 5 is 20. X times x is x squared. 180. And We want to find x first to solve the problem, so let's divide through by 20. And these divide out here. And x squared then give me 180 divided by 20 will give me 9. Solve for x, take the square root of both sides, we get 3. So we're solving x squared equal to 9. So again, we don't say plus or minus 3 because we're dealing with lengths, dimensions, so don't want negative values. So here we know then that x is 3, so we know that the height is 15. The base is 12. So we want the perimeter. Perimeter for the rectangle, twice the base plus twice the length, or twice the altitude. Or if you're thinking of just regular things, twice the length plus twice the width, whatever. It doesn't matter, it comes out the same. So multiply 12 by 2, we get 24. Plus multiply 15 by 2, we get 30. Perimeter is equal to 54 units. So find the perimeter. You got that. And then we want the diagonal. The diagonal would go this corner to this corner, or this corner to this corner. It doesn't matter because we have the values that we need. So in this case, let's call this D for diagonal. So you can see here again, we're going to use the Pythagorean theorem again here. Because this right here forms a, and let me write this a little bit neater here so you can see it clearer. Here's your right triangle. We know a rectangle has all 90-degree angles. Well, that forms a right triangle. We know one side to be 12, the other side to be 15. To solve the triangle, again, the square of the hypotenuse, in this case it's D, that's your diagonal. D squared should equal 2. 12 squared, that's 144. Plus 15 squared, that's 225. Is equal to 369. Okay, so we got the perimeter here, and then we got D squared. The length of the square of the diagonal is 369. So we take the square root of both sides and round it out to one place. Say this will be 19.2. Again, this is just units. 54 is just units, not area. It's not area, so it's not square units. So the length of the diameter, or diagonal, I should say, is 19.2 units. And the perimeter is 54 units. 19.2 units for the diagonal, and 54 units for the perimeter. Thanks for watching. We'll see you next time.